And I welcome you as my name is Andrea Vaughan. I'm the founder, one of the founders of the European Champions Alliance, and I'm really happy to welcome you to this webinar this morning in our focus group on smart industry, hosted by Ingo and Philippe, and hosted also in cooperation with the CIFA, the Club Économique Franco-Allemand, where Oliver Ness will have some introductory words for us in a second. He is member of the board at the CIFA and also one of the co-founders of the CIFA. So thank you very much, Oliver, for organizing the second webinar with us already in the life of the European Champions Alliance. And without further ado, and to not lose any more time, I will give the word to Oliver to say some words. Thank you.
Yeah, warm welcome. I will be short. It's indeed the second event we organized. We have decided to work closer together, and we know that we are quite complementary. The German Business Club, CEFA, is based in Paris, represents some 350 top managers of German and French companies, more in the industry and in the corporate world, and therefore very complementary to all the members of the European Champion Alliance, which are more startups and scale-ups. And Industry 4.0 is a topic with which we are dealing every day, where we're making huge progress. But we are aware that the subject of data analytics and artificial intelligence is a subject we are still struggling with in the industry. And that's why we're really curious to know more about it in the coming 1 hour. And I hand over to the moderator to get started. Thanks a lot.
Yes, so my name is Ingo Franz. I'm moderating today's session together with Philippe Herbert. We are both jointly heading the Smart Industry Focus Group for the ECA.
I see that Ingo is frozen.
I would like to.
I hope he will come back. I'm really sorry for the technical inconvenience. I will contact him too, so he reloads his
topic,
session.
which is basically today all around data. We believe that industry undergoes really a paradigm shift because data has become one of the key critical elements. Some people say it's the new oil. And it's not only that companies collect many data, but it's an all data ecosystem, which comes with connected products and digital value chains. So I think that over the last 10 years, many things have happened in digital transformation. The products got connected, equipment and processes produce a vast amount of data. You could say every second. So at the same time, data technologies and the cloud computing in particular provide an unprecedented power of processing power for data. And that's actually what makes it possible to make use of data. That's our understanding, and that is a key enabler for using as well artificial intelligence. So I think a key topic should be how we make this power of data and artificial intelligence usable in the industrial context. And for me, a question would be basically, can we learn with all this data and intelligence, can we learn the behavior of a plant? Philip, you want to say some introduction? Philip, you are on mute. I would continue. Philip seems to have some problems with the speaker phone. So basically, well, it's one side a technical question, whether we can really learn how plants and machines behave and predict them. But at the same time, it's all about capturing value. So so many euros have been invested to actually put this flow of data in place. But the question is now for us, has there been strategic advantage derived from this? or significant cost savings and efficiencies. So that are the key questions for our today's speakers. We don't want to talk in theory, but we really want to have experts telling us their experiences. So we invited two parties, which I would call more from the startup and tech champion stage. That's on the one side, Cleverdist, a startup from Geneva. And we have a company from Bonn, which is Nexocraft. And we have, on the other side, we have two people from large industry. We have Thales, the French group, where we have Eric Amdar as the technical director of customer services. And we are very happy to have also Ralf Schuster from Infineon. He's vice president of operations, to tell us about their experiences on artificial intelligence projects and capturing, let's say, value from data. So enough of introductions now. I would like to hand over the word to Paul-André Mignon from Cleverdist to tell us about, well, his company and about his, let's say, offer he is using to bring artificial intelligence and data analytics into industry.
Thank you. Yeah, can you hear me?
Yes, we can hear you.
Perfect. Thank you very much. So thank you very much for the invitation. And yes, I'm Paul-André Mijon. I'm board member at Cleverdist. Can you see my screen too at the same time? Yeah. Okay, so yeah, clearly enabling a smarter industry with artificial intelligence and data analytics has started, for sure. We, Cleverdists, are uniquely combining industrial profiles and world-class data scientists from the CERN in Geneva. We are growing fast in this field, helping corporations in manufacturing, utilities, transportation industries. We are helping corporations such as Honda, Siemens Gamesa, and others in this very topic. So how are we helping these corporations? Well, first of all these industries have one point in common. They are very asset-intensive industries, and this is our focus. MyOT, our product from Cleverdist, is a 4.0 solution that is a combination of IoT technologies, industrial control system technologies that we are offering as a service. This diagram summarizes the main components of MyOT. There is a MyOT box, which solves the connectivity question to nearly any equipment. And of course, the communication is secured back to the MyOT platform. MyOT platform has very important features. We'll see later, in particular, the MyOT engineering platform. The MyOT platform is open and can integrate with existing business applications, such as ERP or MES. And the MyOT platform is also where the MyOT applications are implemented. They are specifically designed to create value fast. They are web-based access to applications, to these applications, for operators, for remote management, provide the service from these applications. But what I would like to share is the use cases right away, to see what kind of impact we are managing to bring with such integrated solution. I'm available, of course, in the discussion phase for the use cases. What I would like to emphasize first is the speed of impact and the magnitude of impact that we are bringing with MyOT across manufacturing, utilities, and transportation industries. As you can see, this is substantial. The impact is from tens of K to more than €1 million impact. And this is also quick, from weeks to a few months. So overall, this is how we are successful with our customers today, since we bring value now to them. But let's share more of the reasons why MyOT is effective. The first reason, you have probably guessed it, is that MyOT brings tangible impact very shortly because it is convenient to implement. We are somehow skipping the engineering phase, which is usually very heavy with usual solutions. This approach is in fact quite unique, and it's allowing our customers to extract the value right away. The second reason is that fundamentally, now that the access to the data has become much easier, then we can enter consolidation of data from multiple systems and implementing end-to-end processes. Let's take one of the use cases that I was showing just before, the digital terminal operations. In that case, we have reduced the cycle time by 20% of loading and unloading operations of petrochemical products from trucks to reservoir and reservoir to trucks. How did we reduce that cycle time by 20%? Because we have consolidated data in a sort of digital twin from the reservoir control systems, the access control and site logistics control systems, security systems, all together, including integration with the ERP. And eventually, we have enabled that end-to-end digitized process, achieving this outstanding 20% cycle time reduction. That's clearly big value for our customer. The third reason for success of MyOT is because we keep being very pragmatic between artificial intelligence, data analytics, and machine learning opportunities with plug-and-play applications. For sure, these are real opportunities, but they still require very often some time, which is in fact the learning phase of this technology. So by balancing the industrial background and the data scientist expertise and blending these two approaches into the design of our applications, in fact, we are finding out shortcuts for business impact.
1 minute left.
An example would be the predictive maintenance application that we are using, and that is not only benefiting from machine learning approaches, but in fact, leveraging existing knowledge of our customers' teams. The fourth reason, last but not least, is that the MyOT platform is having the engineering platform. For customers willing to go beyond the application, we can boost productivity for structuring data and building business logic. MyOT platform is additionally a real industrial solution for data governance. Let's have an illustration of that one. Data is the new oil. We provide means for organizations having common goals to share their operating data in a controlled way. Platforms talk to each other, but they control the data exchange through the technology. This is confirming our positioning to offer industrial standards for Industrial 4.0 solutions.
Oh,
to conclude,
thank you, Paul.
As a conclusion, we are matching industrial standards, have this combination of industrial and data scientist experience, and we are industrializing solutions for the sake of our customers. And this is how we bring value now to them. Thank you. Thank you, Ingo.
Thank you.
Yes.
Thank you,
very much.
Paul-André. Could you stop sharing? Yes.
Yeah, sure.
So we are again in the main room. Thank you very much. Well, I was quite surprised when I met Paul-André and talked through the use cases in industry. And it's not the first time that CERN has produced a magnificent product. I mean, we have to learn that CERN has also invented kind of the key technology for the internet. So that's pretty interesting. And I think we have a different view now from another startup and tech company, which is called Nexocraft. which has, I think, a very comprehensive solution and tool set to bring artificial intelligence tools to engineers. Oliver, would you start to explain us what your experience is of applying these artificial intelligence tools in production?
Definitely. First of all, can you hear me? Can you see the screen I'm sharing?
Yes, we can do that.
All right, then let's jump into. So yeah, hello from my side. My name is Oliver. I'm the founder, managing director of Nextocraft. So Nextocraft is a young technology scale-up based in Bonn. We are founded in 2016, and what we are developing and operating is an AI-based digital twin solution that helps engineers improving the performance of industrial assets. So, and I mean, what's now the real pain point? And let's take it from an engineer's perspective. I mean, our target group is either service engineers at machine manufacturers or process operators at production sites. And those must ensure highest possible machine availability, right? And at the same time, they should increase the production output at a given quality level. And that, in addition to plenty other tasks, they have to run in parallel and plenty other responsibilities. So to sum it up, I mean, as an engineer, I really do have to perform a tough job. And on top of that, unfortunately, I can't perform this job without taking a huge risk of making wrong decisions. And to get rid of this risk, it would require a tool in order to test process adjustments, let's say in a digital way, before applying them to the real system. And such a solution is usually called digital twin, right? And these existing solutions are costly and super complex to make. So what we did is we introduced the next generation, and that one is made for the engineers. In terms of our solution, that allows engineers to really make sense of the limited amount of the available data. And I can't even stress this point enough, because big data is simply not existing in industrial production, right? So my screen is gone. A second. Is really not existing in industrial production, explicitly not in a discrete production process. Plus, our solution supports now the engineer to really simulate and test, let's say, new input parameter sets without being a data scientist. And that means there's no machine learning skills required and also no coding skills. What we do is we provide AI support in terms of a digital assistant to boost the equipment effectiveness by 20% plus, what we've seen across multiple industries, right? And I will follow. Or let's say, not before moving on to the real use cases, let me shortly explain our approach in general. So imagine there's usually when it comes to production process, there's usually plenty of devices, of gateways, different data points that are coming in different qualities and quantities. So the very first step usually is really that we put all data together that belongs together, and that talks to the digitalization piece, right? Industrial IoT. And then the second step is we train based on that data. We train a data-driven representation of the industrial asset in order to optimize its effectiveness, which talks to monetization and thereby to the AI part, right? So now let's move on to the blow molding example I'm going to present here, and and let's take the journey from customer's perspective. And this example here, OEE optimization of blow molding machines in the plastics industry. And I mean, for sure, as you're aware of, right, the overall equipment effectiveness comprises of availability, performance, and quality. So in that specific case here, the very first step is to ensure highest possible availability of the blow molding machines. And this is achieved by the so-called industrial health scoring. So what we call industrial health scoring, right? It's imagine it's like an inverted anomaly detection where we compute health scores for each sensor, but not only for each sensor, but also for subcomponents, major components, and then we consolidate it on top level for the entire production site in order to really make sure that there is a highest availability, right? That's point number one. Point number two then is step number two is to really reduce scrap. And due to the curing process, and that one is very specific to the plastics industry, to plastic blow molding, usually quality issues are detected hours later during quality inspection. So obviously there seems to be a time gap between quality a quality issue occurs and then once it's detected. And what is required is an inline quality prediction to immediately observe quality deterioration and react accordingly in order to avoid scrap. What is in effect of that? And once this quality prediction works in a way it's expected to be, the very first then the following step, the third step, is to, let's say, to control the quality impacting set points, right? And I mean, therefore we feed the quality prediction from the previous step into a control policy model in order to maintain a certain quality level. In other words, I mean, to keep that quality stuff within predefined upper and lower bounds. And then the first step and final step in this stuff for this example here is if the constraint of good quality is achieved during the production, then additional optimization criteria can be added to the control policy. And in that case here, we are talking about output maximization, so which aims to shorten then, let's say, the make span or cycle time. 1 minute left. Okay. I'm speeding up here. Next example is HVAC, heating, ventilation, and air conditioning plants. And now this here is raw material processing. We are talking about. So what we do is we take all the data streams from the building management system in order to train a virtual clone. Next step then is that the trained model is fed with a time series predictions such as weather forecasts, occupancy forecasts, as well as production schedules, and thereby the twin simulates thermal demand over time. And finally, this demand forecast will drive intelligent energy supply so that operation runs as smoothly as possible. Final example is process air in industrial production, and there's actually two goals in parallel: availability and efficiency. So in terms of efficiency, it's very similar to the HVAC air controller I already explained. So now let's really focus more on the availability part. And in our example, the process air system is, so to say, mission critical, right? That means availability is of highest priority. If the process air stucks or strikes, right, the entire production stops. In order to avoid downtimes, the plant here is retrofitted with a bunch of sensors, as you can see, like air quality, particle density, vibration, etc. And that data is pushed into our dynamics core, so the heart of our solution, and is used to train the twin. And the twin's actions are then what we do is we take the twin, the twin's behavior, let's say, is predicted over time and compared to the real system's behavior. And in case of observed divergence of the physics and the virtual plant, so if it goes into different directions, maintenance triggered, and the service partner performs maintenance tasks like replacement of filters, etc. Plus, the workflows can be managed more effectively. That results into planning more in advance instead of reacting to failures. So last slide. Thank you very much, and let's empower the industry with AI.
Well, thank you, Oliver. This was a little bit of a rush for the many good things you have to tell. I mean, what I'm really impressed in is
I was pushed by
particular
time. Sorry.
that you are able actually to be a central part of the production management, and we will see much more from this, I think, in learning, in particular in process industries. That I mean, if you can avoid a fault at the beginning, you save so much money over the entire process. So that's very good. I have to say, I learned as well that you have a kind of plug and play platform that is even in the cloud hosted, so you don't need to build a entire system. You can start small. Is that right? I mean, let's discuss later. But
Right.
great examples. So now, after we heard two, let's say fast running small companies, now we will hear the first fast running big company. So Ralf Schuster, I mean, you have a huge production to take care of. You're heading. But I learned as well that you actually had as well the project of to implement artificial intelligence in Infineon production. So we are very interested to hear and learn more about that.
Yeah, thank you. I'm happy to present or to talk a bit about actually what is our practical experience when we implement data analytics and AI solutions in production. Production basically means a big production at Infineon. So Infineon is a company, I think possibly all have heard about it. We have about 46,000 people. We actually have more than 19 production sites worldwide. And we also have a quite big variety of semiconductor products, so spanning all the way from small discretes, which are very tiny, all the way to multi-core microprocessors with 500 electrical pins and connections. And on the other side, very heavy, high-power modules, which are actually heavy as much as, for example, a kilo per piece. So that kind of gives you a bit I think the landscape that we are operating in, and of course also the challenges that we have. Now, why I'm here, as I already introduced, I'm heading part of operations, actually, the testing and the automation technologies in Infineon operations. At the same time, as mentioned, I'm also responsible for the AI at operations program at Infineon, which exactly targets to introduce digitalization and AI in operations at Infineon. And thirdly, I'm also actually responsible for a EU program, which is called AI for the Digital Industry, which is basically actually a consortium of more than 40 partners from universities, from research institutes, and also industry partners to really make sure that we kind of push those solutions within Europe. Now, what are the main focus areas that we have for AI or for data analytics in a company such as Infineon? And I think I'm actually quite happy to see that the two presentations before me are really exactly actually also focusing on topics that we also have. So the question is, how do we use the large amount of data that we collect as our products run from front end to back end to test all the way to our customers, collect all this data and trying to basically get additional information out of it. And we basically have sort of 4 focus areas that we are focusing on when we want to make use of this data. The ultimate purpose is always, of course, to improve our productivity, so get higher, as already mentioned, efficiency of our equipment, higher yield of our products. And also very important for a company such as Infineon that delivers a lot to the automotive market is quality. So quality is one of the differentiator, and using data to improve our quality is really paramount for us. Now, what are our focus areas? I mean, it was already mentioned, and this is definitely core of what we are doing is predictive maintenance. I mean, maintenance we've done for a long time, but really understanding the health of our equipment, reacting early is really important for factories that have hundreds and thousands of equipment in the fab. The second topic is anomaly detection, also mentioned before. So we really, if we can basically find out from distributions, from patterns in our data, bad devices, weak processes. I mean, this is really essential for us. Again, for our zero defect approach, but also, of course, to make sure that we gain stability in our production. Third topic is virtual metrology. Virtual metrology is for us also a great step forward. Virtual metrology basically means that we can predict certain quality and performance out of data that we gain from mostly from the machine, so that we can actually save having an external additional inspection. But what is even more important, we can take the data for each product, and we don't have some sampling where we only can actually measure some of our products. So it's really virtual metrology again is something that we extensively start to use, and it's really a big step forward. And last but not least, connected to that is defect and image classification. So basically using the many, we look a lot at our products as they run from wafers to packages all the way to the customers. We look a lot at our products, take many images from all sides of our products, and basically understanding which is a good and which is a bad product, and basically use all the learning and deep learning approaches in order to find out good versus bad, but also to understand the root cause that we need for improvement is really important. Now,
1 minute.
Where do we stand? We have, as mentioned, we have implemented many of those use cases in our various sites. Now, what is the challenge? The challenge is really now to scale these use cases. To scale these use cases, as I mentioned, we have many sites, we have many products. You can imagine in one, if you develop something like this for one machine, predictive maintenance, you have to make sure that you can scale it to the other 50 machines in a site, and the other 100 machines in the other 3 or 4 sites. So that's really one of the important topics, scaling it, making sure that we can get this benefit not only for a limited small application, but really across all our production landscape. The second challenge and way forward for us is connecting the topic. So not just looking at machines, processes by themselves, but really connecting the data ultimately all the way from the data that we get out of R&D all the way through production to the customer. And actually the customers are highly, at least advanced and leading edge customers are actually even willing to appreciating and even willing to pay for this additional information that we deliver with our products, because they have much more information that also helps their quality in their applications, because we don't just deliver a spec sheet, but we can deliver also data connected to the products that we catch to them. So that's basically, I think, I guess the experience we have. So maybe to summarize, we are quite, I would say, successful in applying all those topics that you already have heard also from the various talks before. Main challenge is really scaling this up and connecting the points within manufacturing all the way to the. Thank you.
I have the mic, I will try to introduce ECA member, because if Infineon is a ECA member, but Thales is also, and we have this two persons, Eric Anga and Philippe Beda. Thales is one of the most important high-tech defense European company, and you have a lot of things going. The artificial intelligence analyze and process. Expecting that you share with us some of your experiences, maybe also the how you see the artificial intelligence and the human interaction. Please, it's up to you.
Good morning, everybody. I don't know if you see the slide. Yes?
Yes, we can see it all okay.
Okay, thank you. Philippe and me are from Thales Group, and we work for Defense Mission System, GBU, Global. We are in charge of customer support and service activities, and we developed from 4 years applications of artificial intelligence. The applications are dedicated to maintenance of electronic devices embedded in military aircraft. Philippe will present you how we are going from curative maintenance to predictive maintenance.
So, hello everybody. So my name is Philippe Beda. I'm data scientist at Thales MS, and today I'm going to talk about the predictive maintenance of the Rafale, the French military aircraft. So what is predictive maintenance? It is a good example of application of AI in the industry today, and it is a new concept of maintenance which consists in predicting breakdowns instead of just having to repair them. And by anticipating such events, we tend to offer for our customers new services, very, very valuable services, and we also intend to create new opportunities inside Thales to make our supply chain more efficient. So all of this works. In this slide, you can see at the left the data that we use. And of course, here the data is the core resource that we need for such applications. And there is basically two types of data that we need. There are what we call the flight data, which are collected inside the aircraft during a flight in real time. And there are mainly what we call sensor data. We can monitor temperatures, tensions, intensities, for example, inside the equipment. And then we also have what we call industrial data from our databases written by our technicians after each repairs. And these data enable us to rebuild the whole life of any equipment. So these two types of data are gathered and joined inside the secure big data platform, which have all the hardware and software needed for data science, but also a security layer, which is absolutely required for military applications. And then work teams and data scientists build machine learning predictive models, which means these are algorithms which are trained to predict the breakdowns by recognizing some patterns in the flight data, for example, temperature deviations or the conjunction of which are correlated with the failures. And finally, once the model is trained, it can be used for many valuable applications. So at the right of the slide, you can see first that we intend to use them for our customers, which are the military forces. And their key concern today is the mission success. So we intend to use the predictions for decision aid, and more particularly to choose the right event which is most suited for a critical mission. Then we also have some opportunities inside the Thales Group. We intend to use these algorithms to obviously to optimize the logistic of the supply chain by predicting and anticipating the events. But we also intend to offer services for technicians by creating tools helping them to repair faster and to find more quickly which part of the equipment is responsible of the breakdown. And finally, the models that we build are able not only to learn, but also to explain us how the breakdown appears. And this correlation helps us to understand how we can improve the design of our equipment in order to increase their reliability in the long run. So if you have any question, feel free to ask. I will be pleased to answer, and thank you for listening.
Thank you, Philippe.
Well, thank you to Eric and Philippe. I think we can. Yes, thank you for sharing your presentation. I think we start now after having heard four companies with their actually use cases for data and artificial intelligence. We would like to start the second part of the event, which is basically a debate, and I would encourage all participants of the panel to join that questions Q&A. And after, let's say, 20 minutes, we will have, we had a little delay, but we will have then at the end a bit of opportunity to ask questions that are brought forward through the chat. I can only invite all the participants to use the chat, and if they have questions to the speakers, let's do so. So Philippe, you wanna start? Philippe Herbert.
I would start with our two champion, or at least the companies presenting innovative solutions in the data intelligence, and particularly I would like to that they express why their very large customers, but the same for next, go to them instead of develop, because Neon and Thales. In large group, you have always the and if Paul-André and maybe I would say Oliver could choose their solution instead of doing.
Okay, I can start. Thank you, Philippe. Well, overall, I think the main reason is because we bring value to them. But if we go into more details, Crevedis is having a very good knowledge of the entire technology stack that are required to make it happen. And I would say it's a very practical experience. So one reason is because we have this complete view beginning to end, from the data to impact, and this is very important. In terms of applications, it's very clear that the large corporations are naturally intending to develop their own applications, but at this moment, the tools that we provide in terms of engineering the solution, engineering the application with the MyOT platform is also quite a differentiator, and we are licensing to Siemens the MyOT platform. And what does this one bring? It brings productivity when it's about developing solutions. It brings scalability. I could hear the challenge, but in fact, clearly it can grow because we are taking care of the data structure, business logic, in a robust way with quality, unit testing, and so on. So scalability is there. And we have the data governance. The challenge of sharing data is clear, important with partners. And we have this technology embedded in the MyOT platform to have a controlled data exchange with partners. So the reasons why the large corporations come to us is practical understanding of what's going on. Second, robust solutions to speed up the implementation of their requirement. That's mainly why.
Okay.
Well, thank you, Paul-André. I think that you put forward one topic which is very important, and that's governance. In particular, if you share with your suppliers and your customers data, it is I think very important that you control who can actually own what. And as we in Germany, and I'm sure as well in France, for example, export many things to China, or the big companies have subsidiaries there, I think this data governance is key. But I would like to extend the question of Philip to Oliver, and because I heard a little bit between the lines that you're not selling so much your tech stack, which seems to be good, but you are selling a lot what I call data to dollars. I mean, how can you derive from data, I would say, dollars, or in our context of the European Champions Alliance, to euros, of course.
Yeah.
Could you give some insights?
Yeah, well, I mean, first of all, usually we are not pitching technology. We are more focusing on the business outcome, right? Because that makes lots of sense to the prospects out there. That's for sure. In terms of our targeted segment, also I have to mention that we regularly focusing on mid-sized production plants. The reason behind is also very obvious, I would say, because they do usually have much shorter cycle times or let's say lead times until to get something up and running. What we do also on the corporate level is that we put our technology solution into super comprehensive commercial package so that they can really use it in terms of a freedom strategy, right? So whatever they do in parallel, they can test us also, right, in order to really in order to make a decision whether that potential external solution works in a way as expected, and then they can take it. So that talks to the commercial package. Obviously, on the technical level, we do have some innovations in terms of the twin solution, right? I mean, as I mentioned, right, already in the talk before, that big data chunks usually you might want to have in order to train a deep neural network. That's not existing in industrial production. And what we now did is what we are following is not a big data approach, as those tons of data are not available. What we are doing is we use domain or process knowledge to compensate for pure data quality. And think in a way that an engineer or engineer's knowledge can be injected into our machine learning approach in terms of a meta model, right? Where they can, let's say, define relationships, where they can describe hierarchies, etc., etc. And thus, we are, literally breaking down one big problem into many smaller ones. So in the end, the twin is trained based on the data taken from the production cycles, and that, works like charm.
Well, interesting. To train the engineers, so it's more a cooperative model, it seems. So maybe a question to Ralf Schuster. I mean, we have heard that probably, I mean, the semicon production is very complex, and it's a process with many steps. And if you can probably avoid a fault at the beginning, you save so much time, because otherwise, if parts run through at the end, it's really, or a batch is not okay, then it is so costly. So you shared with us very briefly what you're working on, like visual inspection or intelligent visual inspection stuff. Can you elaborate on that? And is there a room where you would actually say, well, if there are tech companies, startups out there, could they be a partner, or could they be a cooperation? Is there a cooperation model?
Okay. Yeah, maybe I answer it a bit more general. I guess I told you, I mean, the whole implementation of these AI solutions in production or semiconductor manufacturing it has been a journey so far for us. I mean, we started with having our own data scientists that started to try out things, local offline solutions, trying out what they could find out. And among this, of course, also using available deep learning algorithms, applying them to our images that we create on many points in our manufacturing. But I think that the real challenge is to really come from this stage, trying out so that something works and you can do something with all the way to the fact that you have to rely on the system to do a good versus bad decision, because this is completely different. You have to then also convince your quality management colleagues that actually you can ship a device based on a decision the machine makes or the algorithm makes. And that has been, and that not, again, what I said earlier, not only for one machine, but for hundreds of machines, for different products that also, of course, have different, have different properties. So I think this topic is something that I believe is really the main benefit that you can get out of this. So really, again, scaling it across all your processes and products. And here, I think, is where we have learned that you cannot do this just all by scaling up your data scientists. So you start with 5 and then later you have 100. But you really have to think about what is the platform, what is the infrastructure that we need for that, what is also the data quality, because if your data quality is not consistent, then you will not be able to make real consistent prediction. And last but not least is also exactly how do we get it fast enough? Because again, I mean, Infineon will not be able to run hundreds of data scientists, but we have to basically understand what we can use in terms of, again, systems, in terms of infrastructure, in order to speed up the scaling. So here I think we are, of course, already are very active to understand how available solutions, both from small startup, but also from bigger companies, can help us to actually drive this scaling. Because again, I mean, I can tell you we have 19 factories. We have hundreds and thousands of equipment and products. And in order to make really a full use out of this, scaling is ultimately important, and really understanding how this scaling can be handled and supported by a professional and consistent infrastructure is for us ultimately important.
Well, thank you. I think that there might be some companies, even in this discussion, who might be interested to talk. So for Thales.
Yes. So
okay. Yeah,
do we still have the Thales? Yeah. Do we still have the Thales people?
Hello.
I can't.
Sorry, can you hear me? Can you see me? Hello?
Yes. Hello?
Yes, we see you, Philippe.
Sorry, Eric Emgar had to leave at 12 o'clock, so but I can continue to be here with you.
I would like to question for Thales, but which is much more general, as we have I would say activities going on in the maintenance. Is it only in the Thales group that how do you manage and the process with also your subcontractors and your suppliers? How you do that in the broader than the internal data?
To be honest, as a data scientist, I may answer wrong this question, but in my opinion, what we presented today is actually some internal researches, and I don't think that with our supplier there is exactly the same approach. But actually today, but sorry, I cannot be sure of that. So I would say that for today it is still inside the Thales group that we conduct this research. Sorry?
Okay. Well, okay. There has been again a little connection problem. I think that, but at least I think in Germany we understood what you said, Philippe. So I think that it's a key issue. What Philippe mentioned, that many companies actually work across supply chains, and if you talk data, this data is transferred across chains, and how do you apply it? And so I think this is something we might ask again to Paul Andre, if you have experience with that. I mean, how do big companies, which are your customers, actually manage that? I mean, it's often an issue that you cannot provide the data because it's under NDA. It's a difficult point, and maybe you change tomorrow and supplier. Is that something you can manage with your systems, or do you have cases where it has been a problem?
Just to make sure, you mean exchanging the data between our customer and their parties?
Yes, in the supply chain of your customer. Yes.
Yeah, absolutely.
Yeah.
Okay, so yes, it is increasing. It is
managing
increasingly
the overall
important.
data.
Yeah, increasingly important for business partners, our customers, to have confidence in the data that they have versus the data that they share. And in fact, every time there is a process, there is an opportunity to deliver more value by sharing data across the partners. So that's clearly there. But the challenge is to make sure that the trust is established when these data are being shared. And the solution to make that happen is to make sure that there is some sort of consequence to badly using the data, so that there is a possibility to suspend how data are being shared. If we offer that through the technology, which is what we do, and we have patents for this technology, then the requirements, the need to share the data can be overcome to reap the benefit, because the security, if there is an issue, is also there. So the process of stopping it is also there. And it's not about NDA, it's not about legal aspects and so on, it's about the technology doing it. So when partners are exchanging data, then they can always do it in a trustable way. And this is what we're going with MyOT. This is one important feature of MyOT. So increasingly important, the number of customers that talk about this very topic is increasing very fast. And why? Because the scope of opportunities is expanding when we are considering data coming from potentially 2 or even more organizations. So we are helping with them with that, yes.
Okay, interesting. There is a question about from the chat, which is, have you considered resilience of the systems in the solutions? I'm not fully clear what is meant with this question. Resilience in the system. Anybody who has an answer for that? Otherwise, I would come to a different question. So I'm sorry. The question was by Ali Asghari, but I'm sorry that we cannot really answer it. Oliver, may I ask you one more question? Because for me, it's also a question of implementation, because my experience is that often data analytics is a cost center. So do you have a solution to bring very quickly solutions into action without that companies really have to invest a lot?
It's in my direction, Oliver?
Yes, Oliver Habisch.
All right. Okay, great. So yeah, I mean, first of all, what takes most of the time is obviously enabling those plants, those machines, right? So the integration piece. And so in case, let's say the customer or partner is offering some standardized protocols like OPC-UA, MQTT, or REST API, it integrates very smoothly, I would say, right? That doesn't take long. Plus, we changed the logic or inverted the logic, saying, okay, please provide all data points you have, and that's by our flat rate pricing, right? And later on, we can say, okay, let's squeeze it down to the relevant parameters, but that we are not following an approach saying, okay, oh, let's start with points, see how that affects the pricing, and then later on it will be, there will be additional 50 and so on and so forth. So we turned that upside down, saying, okay, once they can provide a standardized interface, we will integrate directly. If it's a proprietary protocol in a brownfield, obviously we will leverage partner solutions. So we do have plenty of edge device manufacturers we are partnering with, and saying, okay, well, that's the lead. Please make sure that they are integrated, and then we take it from there. But in terms of our solution, then later on, once data is fetched and dumped in database, you can then directly leverage the capabilities of our industrial IoT platform, saying, okay, well, come up with nice and fancy dashboards, reports, compute some KPIs, send out notifications, etc., etc. So the basic set. But then what we did incorporate into that approach is the industrial health scoring. So that talks to the normally from the OEE point of view, right? And that usually, and that depends very much on the underlying process or machine. That usually takes 1 or 2 months of data until it can really precisely predict some health scores, and then from there on we can go into various kinds of AI directions.
Okay, so it's in any case it's a project either supported by you or done by the customer himself.
That's actually sorry to may I add something, because that's a very important question you are asking. No, it's definitely not. So we are interested in a product, right? And all that integration and customization part can be done either by our customers itself or by leveraging partner capabilities, right? So that we can really focus on the scaling part of our solution. It's really a SaaS solution, and it has to scale, because obviously we have 35 people on board. We can't do these kinds of plenty of integration projects. Obviously, customers can then book some support and service hours on our side, but the overall idea of the strategy we are following is that our solution comes in a self-service fashion, right? So that the customer can do all that stuff on its own without asking for support.
All right. Maybe I have been asking questions a lot. So Ralf, do you have, for example, questions to the two tech companies?
Yeah, I mean, it's a good I think, and particularly as you may have figured out from what I said so far, I'm particularly interested in this scaling. I mean, again, efficient scaling. And I give you maybe a very specific example to illustrate a bit why this is important to us. I mean, we have a process that is basically bonding wires. So we need to attach our silicon to wires, and then the wires can go to the package, and we can connect the silicon to the outside wood. And this wire bonders, are many of them. And what we have done is we can predict quite well the quality of those wire bonds by looking at the data from the machine or from the process. But if you have done this for 5, it works quite well. They all behave very similar. But then the maintenance guy comes and does a change in the setup, and suddenly the model doesn't predict as well as it did before. No? Same if we now, as mentioned before, go to the rest of the 50 wire bonders in the fab, that they may be a slightly different model or software version. And so the question is, do you you have models or approaches that actually can exactly deal with that? So how can we basically the scaling and also being able to basically adapt to changes, slight changes in an equipment setup, or basically more equipment models that maybe have the same name, but of course they are different iterations of a generation of an equipment. Do you have experience how this can be done in an efficient way? Because this is one of the core topics that we are currently actually interested in.
Okay, let's try. Thank you. I think that's clearly a topic, a challenge. I would bring a beginning of an answer because it's obviously a challenging question. However, what I would like to share is that already when we are establishing the solution, there is a possibility to step back a little bit about what we are looking at, so that already we would have first embedded somehow the scalability, because we would have defined what are the important elements of what we are doing, the process, the machine, and so on. So a little bit of stepping back will help. Then the second step is about quantifying the things, quantifying the challenges. So basically, managing to make sure we understand where the issues are, how important it is, and so on, so that we make sure that we can guide through where the difficulties are. And the last point will be about making sure that we bring the right diagnosis, the right corrective action, even the predictive action. And here we will probably make sure that within some environment with some important variable, then we might adjust how we diagnose the situation, so that we will help the teams making sure that based on the context in which they are operating, then they're getting the best outcome. So in fact, a lot of the question to share a beginning of an answer would be how we are looking at the operations that we are helping with, how we are structuring it in a way that we can next run I would say, the motorway, the process that we are having with the Mayotte platform. So there is a bit of important step at this moment, but if we do it right, then the resilience, perhaps that was the meaning of the resilience, the resilience from the solution to these elements is arriving. But that's beginning. That's very interesting question.
Thank you.
It's up to you, Oliver.
Well, thank you very much. I mean, we would have maybe time for one last question.
There is one in the chat. There is one in the chat, Ingo.
One in the chat.
May I also, let me also quickly answer that question.
Mr. Tabe says,
sorry,
I have a question regarding digital twin in the process industry. A digital twin in the process industry, how much customization they would require before being implemented? In particular, if there's one specific equipment. Is it a major challenge? So maybe that's a question for Oliver, I think, no?
Yeah, so sorry, can I maybe follow up with this one? So really, in a nutshell, right? So our solution is usually deployed on a virtual infrastructure. So whether it's Microsoft Azure or AWS or whatever, in order to make it that it scales from an infrastructure point of view, right? Then the model is a universal data model, which is so to say a horizontal technology, but we execute it vertical by vertical, so it fits for plenty industrial use cases, and thereby obviously we focus very much on the scaling aspects. Now, how does it adjust then precisely over time to process changes? Obviously, that's then done by optimizing, let's say, the meta model, right? That's with the customer. So whenever there is a change in the process, there's machine, let's say, obviously that can be integrated via the meta model and that on the customer side, so that, you know, they can self-service this process on their own. All right, then can you maybe please repeat the question regarding the twins? I can't hear you.
Question from Mr. Tabe about the digital twins in the process industry. How much customization they would require before being implemented? Especially that for one specific equipment, there are many types, sizes, and so on.
Exactly. I mean, the logic is that data models require data, right? So in the first step, we have really to make sure that, you know, the data runs into the system. And then, as I already explained, that there is a, you know, a universal data model behind, which, can you hear me?
I can hear you. Yeah.
Okay, great. Right, because there was some noise in the background. So, and as I said, okay, technology is a horizontal one, and the customization part comes with the self-service interface, what we call Twin Builder, right? The Twin Builder provides the capabilities in order really to set everything up, to, you know, maintain and operate it. And if you have, I'm interested in a deeper look, obviously, we can have a follow-up call on that. Still there?
Ingo, you're on mute.
Yeah, I would anyway suggest if there are any specific questions to the people who have been speakers, we would be happy to share your questions and match contacts with everybody, of course. I think time is running out a little bit, and I want to apologize, first of all, for some technical questions, so we have been starting late. But then I've, at least from my view, the discussion have been going pretty well. So I'm very happy. I'm quite impressed what actually is existing already, what is running. And I think the key answer to our question of the event is basically yes. I mean, it's happening, but what I learned, it's the scaling. It's, I mean, bringing this into the broader context, which might be a challenge, and there I hope that we can help to match between maybe people who have solutions and who have know-how with people who have the issues. So there might be, as far as I understood, some initial possibilities to do maybe develop solutions on that together. I think that definitely data is become basically a commodity. It's there. So now it's the question to move this data into value-adding situations, because all of this infrastructure is expensive. And I'm very confident from what I heard from everybody that we are in a good way to actually deliver this value. I just want to say, as we come to the end of the time, maybe Oliver, if you want to say at the end some ending words, but I would like to point to you in the chat. We have some links to the European champions, to our focus group, and also to the speakers. We really would like to bring forward the call to action. I mean, get involved. I think this European Champions Alliance is a active, I would call it do tank. We're trying to match people. We're trying to bring forward European technology. So, I mean, the easiest thing to learn more about this would be to join the next focus group meeting, for example, in Smart Industry on June 17th. But please look at our website. You will find, I think, also in other areas such as cybersecurity and so on, interesting discussions and interesting groups. So thank you to all the speakers from our side, and maybe Oliver Nass, do you want to say a few words at the end?
Yeah, well,
how did you see the event?
Well, thank you to the participants. I think it was a complex subject, and it was also a challenge to discuss together virtually with some technical interruptions, so that was not so easy. But nevertheless, each of you could show some concrete examples, and I think that's a very important message we can take out here. Each of you had some concrete use cases which are already working. So the beginning is there of this journey, and as Mr. Schuster said, we are on a journey. We are not yet there where we want to be, but we can definitely, by exchanging these experiences, getting faster there. And I would encourage all participants, use these platforms like the European Champion Alliance and the German-French Business Club to get connected and exchange across the supply chain, exchange across the industries. And this can bring really value to all of us. If the links don't give you the answer, do not hesitate to write directly to either the European Champion Alliance or the CIFA, and we really make and will do our best to bring you together with other people who share similar questions, concerns, or success stories. And with that, a big thank you to all of you. And I hope we will soon come again together between the two associations. Thank you very much. Merci.
Thank you.
Und auf Wiedersehen.
Thank you.
Thank you.